Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Prospectives. Go to www.prospectives.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and today we have a great show for you. I'm here alone. I'm solo. My co-host is off on spring break with his kids, but he'll be back soon. But no worries. We're going to have a fantastic show. Today, I have Jereme Kent with me. Jereme, welcome to the program.
Thanks, Chris.
So, as I say every week, I know who you are. I always have the advantage because we've invited you to be on the show. I've seen a little bit of background in doing the show prep. But our guests have no idea who Jereme Kent is, my guess. So maybe it makes sense to start out by telling us who you are.
Yeah, happy to, Chris. So my name is Jereme Kent. I am the CEO, founder, and chief fall guy for One Energy Enterprises. It's a company I started a little over 12 years ago. Prior to starting this company, I spent the time in the construction side of the big wind industry. So I was building some of the largest wind projects in the world. Started out on the turbine erection side and ended up, running entire sites. And for the last 12 or 13 years, I've been building this company and trying to do my best to shake up the power grid a little bit.
So you started your career building wind, and then you went out and said, I need to start a wind company. Big leap there. Maybe tell us what happened. Why go from construction to where you're at now?
I mean, like all good stories, Chris, it involves being drunk at a bar. But I think, I had helped build a couple construction companies on the wind side, who then, after a year or two of me working really hard and being all in, decided to do a strategic shift, and all of a sudden decided they didn't want to self-perform construction. So, do that once, shame on them, get ready to do it twice, and shame on me, I guess. And so the second time I happened to be sitting at a bar, and the bartender said, do you work with the wind farm? And my first response was, what did my guys do? Because, usually when a bartender asks me if I work with the wind project, I'm in trouble somehow. And his response was, no, I just wanted to know, how do I get a wind turbine for the hotel? And I said, look, buddy, why do you care? And he goes, well, I own the hotel. And I said, okay, you know what? I'm just bored enough and I've had just enough drinks. I will commit to promising to get you an answer. And I spent the next, 4 or so weeks figuring out how he could get a wind turbine for the hotel. Ironically, the conclusion was he absolutely shouldn't, because his price of power was way too low because of where he was located. But I realized there may actually be an interesting business model there. And so said, you know what, maybe it's time to give it a shot and just start my own thing. And so I actually started the company to try to go out and build small wind turbines for, businesses and farms and things like that. And over the first year, we kind of quickly realized that maybe that wasn't the right place to put all of our efforts, and pivoted to doing large wind turbines behind the meter for large factories. So that's how we ended up where we are, and have grown and taken on more since.
All right. So you said you went from small to large. Maybe magnitude would help. Are we kilowatts or megawatts? What are we talking about? What's what?
Yep. So the small turbine industry, right, is typically turbines from 5 to 50 kilowatts. Usually they're on like 100-foot towers. I think we actually built 3 or 4 small turbines before we pivoted as a company. But those were 20 kilowatt turbines on 100-foot lattice towers. When we talk about large turbines, what we do now is all megawatt class utility scale turbines. So we've installed a whole bunch of 1.5 megawatt machines and are gearing up to install some 2.5x type machines. So the scale is just different, right? The large turbines are 80 meter hub height, 260 feet. I always on tours say that it's a football field spinning on a 27-story building, and that gives some perspective.
All right. So you build these large wind projects or windmills. It doesn't sound like huge projects. So these aren't fields of windmills. These are onesie twosies, one off for a factory or a large commercial enterprise.
Yeah, so everything that we do is behind the meter. So it's directly powering a factory. Just like if you had a solar panel at your house or a small wind turbine at your house, right? It's directly on your side of the meter. And so by doing that, it's able to directly offset your load. But that's the niche that we found, is that you hear a whole lot about behind the meter solar, and you don't hear a whole lot about behind the meter wind, because there's a whole lot of hurdles you have to get through to get there. And then we had to entirely change the way you build a turbine to build one or two at a time. It's there was a running joke when I was running very large projects that the first 20 turbines didn't matter, right? You'd spend all kinds of money getting set up. You get your reports back on the first 20 turbines, you'd lost a ton of money. But over the next 150 or 200, you made all of that up and made all of your money. When you have a job that only has 3 turbines, you can't lose money on the first 20. So we had to rethink how you do construction.
So do you own these turbines, or are you leasing them, or do folks own them? So if I buy 3 of these, how do I mean, if I have 150, I can stock and spare and have people to do maintenance and stuff. I got 3 of them, probably different magnitude of support and service.
Yeah, that's exactly it. So nobody really wants to take care of those 3 for you but us. I would say that the big difference is that
So we're in the bar again.
Yeah, that's exactly it. So we let customers have the choice. If they want to cut us a check, we're happy to build it and they can own it. We'll still operate it. In most cases, in all of our recent projects, we own and operate the turbines. Because if you're a large industrial and your business is making dishwashers, you don't particularly want to own and operate a wind turbine or have that risk or even try to quantify that risk. It's far easier to pass all that risk off to someone like us.
So for an industrial player, I just don't know.
Yep.
Let's say you do a comparison, wind or solar. So you've got some real estate to do either. Perhaps you're in a location that has wind. How do the economics compare? And then how does the predictability of performance? So people always say renewables are great, except it gets dark at night and the wind stops blowing. So how do they stack up?
So I guess it's worth taking a step back and remembering that the solar industry started small. The unit of a solar farm is still a panel. And so it was the same panels meant to be on your roof that they do more of to get to a larger project. So at the small scale, solar has always geared to be cost effective. And then as it ramps up, it doesn't necessarily get too much more cost effective. Wind was always big, right? Or the modern industry was always big. And so trying to get small, when you look at smaller turbines, doesn't work out very well. So if you're talking about that 100 kilowatt class, that 20 kilowatt class, do solar every single time. Now, when you start talking about utility scale size turbines, the bigger ones, the economics of that get more interesting. The economies of scale kick in. And so what we always say is that if wind works, wind is usually the cheapest. Wind doesn't always work, right? If you're next to an airport, if you don't have a good wind resource, if you don't have land, right, you can't do wind. But if you have a spot that has a decent wind resource, usually the economics of wind are significantly better. The real key is that almost all behind the meter projects in the country and around the world are still grid connected. So you don't have to deal with the stability for that customer because you're still able to pull power from the grid. So on a solar project at night, they're sucking power off the grid. On a wind project, when there's no wind in the middle of July, they're able to take power off of the grid. But at the same time, you can get pretty predictable, and what that looks like. And so on a monthly basis, wind is pretty predictable. On an annual basis, wind is very predictable. And on a day ahead basis, wind is, base load grade predictability. It's all of the what's it going to be next Tuesday that makes it a whole lot more challenging when you try to plan a power system. Does that answer your question, Chris?
It does. So it asks, I envision some sort of software that now has weather forecasts and pricing models from the markets and things like that, so that you can kind of plan for this. Is that integrated this, or how does that work? So I know that next Tuesday is not going to be windy, for example, and I've got a little bit of headwind. I know ahead of time, right? Is that something you guys help the customer manage then? Is to try to get the best price, or are they just getting whatever the market price is from the local provider? Is there other strategies there?
Yeah. So on the utility scale side, when you're bidding into the market, you're absolutely taking a look at that day ahead, 2-day ahead, 7-day ahead. When you're behind the meter, the nice part is that the math is really simple. Whenever the wind turbine makes power, that's usually the cheapest power you can get, take it. Every other time, take what you can get on the grid. Now, what you will see, though, on behind the meter projects is, okay, wind, for example, tends to produce less in the summer. And so maybe you have a summer hedge where you're buying a larger block of power from other energy providers in the summer. And in winter, where wind is performing very well, you're just kind of taking the market when there's a little bit of shortfall. And so we don't have to, in behind the meter projects, get into all of the forward marketing type stuff that you do when you're a traditional mega project. It makes it simpler for the customer. It makes it simpler for us. There's a question about how sustainable that is as you see more of this show up and every customer is doing what's just best for them. But that becomes the real question for the power grid of the future, so to speak.
All right, so that would be something I'll get to. So I'm still trying to figure out. So you put these in. I believe I'm speaking to you in Ohio right now. So you've got a Midwest basically footprint of these so far. Is that where the company is mostly?
Yep. So we're headquartered in Findlay, Ohio. All of our operating projects are Ohio. We're also building one in North Dakota, and working on some projects in between the Illinois, Indiana type areas.
And then, are you using off the shelf then all the parts? Is this all COTS type stuff? So your role is build, manage, and design these projects and taking what's available.
Yep, you got it. So it's doing all the upfront work to figure out where it goes, to do the engineering, the wind resource, the procurement, to buy the turbines, buy the best equipment off the shelf, and then install it, operate it, finance it, and deal with all the legal permitting stuff that goes along with that. So essentially everything that a factory plant manager doesn't want to do, other than take the power, we do.
And then what kind of community support or against? I know here in Switzerland, windmills are not particularly popular. I think I've heard former president speak about windmills as one of his pet projects that he doesn't care for. What's the general population? So folks in Ohio, how do they feel about seeing these windmills around? I mean, I guess people do like renewable power, but do they want it in their backyard?
It's an interesting question, Chris. I think the weird irony of our projects is that they also really don't want factories in their backyard, but they really want the factories there for jobs. And so what we've seen kind of organically happen is that in most communities, the factories are in an industrial district. The industrial district's kind of off on the side of the city. It's out of the way. And not a lot of people live around the industrial district. So our projects tend to be different. Ironically, they're both closer to the actual city itself than most big wind farms that you see, but they're also in the area that the city kind of goes, yeah, that's the industrial district, let it happen. So a project is seen very different by the community when we have a company that has 3,000 employees in that community who's saying we're going to be here for 20 years and we're doing that with these wind turbines. That's great. That tends to get a lot of support, as opposed to a big wind farm that's going to sell power into the grid that has a bunch of leases. It's not tied to anybody really knows. And so we do absolutely get some of the NIMBYism, so to speak, but we get far less of it than you'd think. And usually we have the support of the working class and the leadership class in that community to say, we want this company here, and if this gives that company a global edge, great. That seems a whole lot better than losing that factory. I personally bought the house next to our office, next to 10 wind turbines, and I joked that it's in my online dating profile, so wind turbines have to be cool, right? Looking at them right outside of the backyard. But
so you're not thinking they cause cancer and living next door to them, then?
I have been cancer free so far. It seems like it hasn't been an issue, but
sorry, I couldn't help it. That's just too easy.
Haven't slept well in 6 years, but it has a lot more to do with entrepreneurship than the turbines.
Yeah. So, all right. So you got these large companies. Are they using the grid like you described as backup, or some of them also investing in storage as well?
So at the scale we're talking about, right? These are factories that have a base load of 4 to 10 megawatts, right? The size of battery you need or storage you need is huge. To get a day's worth of power could be 240 megawatt hours of storage. So it's hard to get that scale. About once a year, we take a deep dive and try to find a storage solution that pencils. We haven't found it yet at this scale. I think there's different markets where the price is a whole lot higher that it maybe makes sense. California, the cost of energy is 4 or 5 times what it is in Ohio. So economics are different, but in the heartland type states with relatively low cost of power, we just can't make storage pencil.
Yeah, I'm just curious, right? I don't know your plan. That's all I'm asking. So, but it sounded like you'd said that anyway, that they're using the grid kind of as the backup plan. So when there's wind, they use wind, and when not, they use the grid. What I guess what I then think of, so these projects, what kind of life cycle you talked about, the community development teams not wanting to lose someone. So, you've got a manufacturing facility or I think, a large American company, the names that we may know, working in your community, support large part of the community. They don't want it to go. What kind of length of term are they forecasting for these wind projects?
So far, all we've been able to get out to is 20 years, right? The turbines are going to last longer than that. I can now buy some turbines with a 20-year warranty on them. But from a corporate point of view, in many cases, that 20-year contract is the longest contract that that company has ever signed. So we joke that we tend to always get to meet the CEO, whether or not they want to meet us, because they usually have to sign the contract, just from corporate governance and approval cycles. So it becomes a long-term view for them. Some have started to talk about 25 and 30 years. I think 10 years ago, if I said 30 years, everyone would have looked at me like I was completely crazy. We now have customers who are saying, we'll take a look at 30 years and we'll see. So I think there is a whole different wave happening of customers wanting to take long-term control.
Now, a wind farm would be capital intensive, right? So, in some of those you own, so your investors are doing that. What's the shortest kind of term that one of these makes sense that the performa?
Yeah, it's hard to make the economics pencil sub 15 year just to actually be lower than the cost of power today. I mean, so the real reality is that most customers, will, or most factories will not put up something that costs them more. So if you can achieve financial parity or some financial, incentive, then there's a bunch of great reasons to do it. Actually, looking at spending more is a challenge. So most of our customers, need that 20-year term to get that cost where it needs to be.
Now, but do they realize that when the project kicks off, right? So you're taking the risk on it with the 20-year contract, but they realize cheaper energy the moment the project's up and running.
Exactly. So most of our customers to date get somewhere between a 5 and 10% savings day one with no upfront cost. And then we just own and operate it, and it's locked in flat for 20 years. I have one customer, Chris, that wanted to make a point, and so we worked with them, and we actually signed a 20-year contract where the price of power goes down every year. So for 20 years, it's not a lot, but there's a percentage decline every year for this customer, just so that customer could turn around and say to his board or anybody else who gave him a hard time, you know, look, the price of power is guaranteed to go down every year for 20 years. Why wouldn't we take that deal? And it was cheaper than we have today. And, there's no reason that others shouldn't be doing that too. It sure seems like we should be able to get the price of power to go down with time. Everything else seems to go down with time, but somehow that never seems to happen.
So, they've got the performa in hand. What makes a good ideal customer for you? I mean, you've talked about the scale, so that's part of it. What are the things that someone should call you if I meet these 5 requirements or these 3 things? What makes a project at least make sense? So I think you talked about wind in the area, and there's some other. I imagine there's some zoning and some other things of that line in, but maybe you could tell me.
So the ideal customer is at least 3 miles away from an airport, right? Because we have all kinds of issues being too close to the airport as a tall structure, and these don't do well short. They have land around them, whether they own it or not. They use at least 5 million kilowatt hours a year. That's kind of just like the magic number where it starts becoming effective to be big enough. And beyond that, the rest you have to work through at a more technical level. So that tends to be the screening criteria we use too. Um, we found that works for about 30% of large industrial facilities. So there are 53,000 large industrial facilities in the United States. So those are facilities that have more than 100 employees and are likely the large energy users. And we've done some studies and basically shown that depending on the subsector of that, anywhere between 20 and 40% of those are remotely located far enough away from airports and have land around them.
And then your business model right now. So you started in the Midwest. You're going wider. Where are your ambitions to go? Are you a regional player then? Are you a North America player in the future? What's your vision?
See, now I wish I had my Pinky in the Brain coffee mug here with me so I could talk about world domination. Um, but the long-term goal for us is to be everywhere, right? Is if they're using energy someplace, we want to be there helping the CNI do it. And so we're going to be in the US for a while before we go expand to the rest of the world. But the same customers we work with in the US are some of the largest energy users in other countries around the world, and they'd love for us to be there too.
And when you say for us to be there, that's a partnership then that you envision working with them. So do you go back then and every time you do one of these projects, then you have an investment round type of thing that goes, or do you have a pool that you go through? How does that work?
Yeah, so the capital's interesting, right? So we had to figure out how to do capital for smaller projects because the capital that you want to get to, the big energy capital, the infrastructure capital, doesn't like $5 million deals. They want 50 to $500 million deals. So we've taken a couple different approaches. Early on, we used some family office money that was more flexible and able to do that. As we got into some bigger infrastructure type stuff and some debt stuff, we had a fleet where we could draw down on the fleet. Um, by far, the most cost effective thing is to do the fleet on balance sheet and then put it out to the market. And that way, you just put an operating fleet out to the market, and a whole bunch of the upfront risks go away. But we're constantly raising capital from different structures, and we're seeing that price go down. I mean, the first term sheet we got for a project, 10 years ago was an 11% cost of capital, and we're now talking to guys about 5.5 and 6% cost of capital, and that's tremendous in what that translates to for this industry. So you're seeing the capital markets figure this out and figure out distributed energy more and more.
So is there a saturation point, or are we just can you just keep doing this as fast as you could build these? How many capable industrial sites are there, and how quickly do we hit saturation between you and competitors or competing technologies?
We have a long, long, long way to go to get anywhere near saturation, right? You have retiring large power plants. The average age of a power plant on the grid in the United States is still like 45 years old or something, even with as fast as they're shutting down the old ones. And so there needs to be new investment. If you think about what a power grid of the future might look like, it'd be nice to have a lot of that investment be private and not be, big regulated utilities or IPPs. And so I think you're going to see a whole lot more of this distributed energy behind the meter type stuff with private investment. The other thing that does is, I mean, you talked about NIMBYism earlier. You think it's hard to build a wind turbine, try building like an interstate transmission line. And so I think I even heard you guys talk about it on the show, but building big transmission lines is very difficult. If you can build distributed generation, especially, and you can take down like the 26% of load that large industrials represent, you free up a whole lot of additional capacity for the transmission system to work better for everybody else.
So I get the freeing up, and I get that. I guess, are there recs, or are people getting credits for doing? Is this part of making these models work? Is that how the price comes down, or is it surely the cost of putting in the infrastructure that brings the cost down?
The rec market in Ohio isn't exactly the best rec market in the world,
Okay.
but there is some value to recs. Ironically, the green e-recs, I don't know if you're familiar with green e-recs, but essentially the just open source can be from a wind farm in Texas anywhere type recs.
Oh, yeah, yes.
The price of that's up 3x from where it was 2 years ago. The price of state specific recs has not gone up nearly as much. So there definitely is a corporate buying frenzy happening right now that's throwing those rec markets in some weird places. But in general, they don't need to happen for the price to be economical. It helps.
Okay. So it's not one of the indicators. It's not one of the criteria of like why someone would do it. They don't need that to happen.
That's correct. I'd say the biggest driver is, the federal tax credit that's been phasing out that now is supposed to come back. The interesting part is even for projects that don't need the tax credit, the worst thing possible to have hanging over your head is that it might be 30% better if you wait just a little bit longer. And so that causes a bunch of problems where you go, look, just make a decision, give us a yes or a no. But saying that you're working on a 30% extension is about the single worst thing you can do to a project anywhere.
Right. So help me as a neophyte to wind. Um, what is managing? Let's say I have three of these behind my plant or some open space. I'm 3 miles from an airport. I've met all the criteria. What needs to happen to have consistent good power?
You really don't have to do much. So as long as the grid's operating like it should, because the wind turbines will shut down if the grid has a problem for safety, they keep making power. You'll see that turbine spinning about 93% of the time. It's not making full power all that time, and it'll just make power. The service schedule for these turbines has gotten much better from where it used to be. Scheduled maintenance is twice a year, so you'll have technicians that come out twice a year and go ping bolts and make sure that they're all the torque specs are right and all the power cables look right, but the maintenance isn't anywhere near what it used to be. And then you deal with unscheduled activities that happen, or most of our events happen to be problems in the power grid, right? We see a flicker in the power grid, and actually the way the law works, we're required to think that's a bad thing, and so we shut down and trip, and then we get a notice that the wind turbines tripped. We have to check the system and go, okay, the power grid's restored to normal. Go ahead and turn the turbines back on. But all in all, availability on these systems is 97, 98%. So as long as it's blowing, they're spinning.
And what about tornado alley, or the thought that the Midwest may have tornadoes from time to time? Do you put your wind turbines next to trailer parks? I mean, Sorry, I couldn't help it again.
It's all, I get it. No, so wind turbines actually do very well with high winds. So what most people don't realize is that the design cases they examine for wind turbines are pretty out there. So the governing case for a lot of turbines is that the wind turbine was pointed the wrong direction, then the power grid failed so it couldn't move or protect itself, and then the ultimate high wind event came, and so it tries to twist the tower down because you aren't pointed directly into the wind. And you have to design for that extreme wind speed in that case. So now if all of a sudden you're pointed directly into the wind, your blades are where you want them to be, everything's working like it should, you can take a much higher wind speed. So, every once in a while, a couple times a year, you have a tornado that takes a direct hit to a wind turbine and you see problems, but it takes pretty much a direct hit to actually take one out. And even in those cases, most of the time the blades fail. So,
Okay.
Have you seen the pictures of blades of wind turbines are kind of bent over and laying down on, but still attached to the turbine?
Okay.
So we jokingly call that like sad rabbit, but it's actually a design feature. So those blades are designed to fail without falling in a high wind event, as one of the primary mechanisms, so that way you can just go replace the rotor and not replace the whole turbine, and the turbine doesn't fall over. But the tower itself can take obscene wind speeds. So the tornadoes aren't the problem. Hail can do a lot of damage though. Go take a whole bunch of 1-inch hail and throw it at a bunch of your fiberglass boat type stuff. It's the same material that blades are made out of, so you can get chips from that. Hunters who decide to shoot at things is always a fun problem in the wind business, although not so bad next to factories. But in the middle of nowhere, I had a project that had a shooting range in the middle of a wind farm, and you just kind of looked at the poor turbines downrange, and you're like, I'm sorry, I don't know who put this here, but you're going to be getting bullet holes out of your blades for the next 20 years. So.
Okay, so basically what I heard you say, the maintenance is a couple times a year, a service crew goes out there, just checks all the specs, make sure the thing stays within spec. They do whatever preventative maintenance. And then is there a major overhaul, at 10 years, at 20 years, when is there another big infrastructure investment? I mean, I know you said that they're warranted for 20 years, so you're expecting to get more than 20 years, but are there some services along the way, blades changed, or other things changed that are massive during that time?
You're starting to sound like my banker, Chris, asking where the money comes in. The base case is really that you don't have to do a substantial investment during the 20-year life. I think there's a lot of question across the industry about what happens after 20 years. The main problem being that the wind industry is really barely about 20 years old with the modern, turbines that we deal with today. So everybody has their opinions and no one has real good data. When you have gearboxes, which the turbines that we use don't have, yep. Gearboxes tend to get a major overhaul by 20 years. The real wear parts are blades and cables in the turbines that we have. And so I think you're definitely going to have some major fiberglass repairs at some point, whether that's 12 years, 20 years, 30 years, you're going to be doing a lot of fiberglass work. And at some point you're dealing with some cables that have been twisting back and forth for 20 years, but there isn't a scheduled major overhaul anywhere in there.
Got it. That's pretty cool. And then do you have responsibility over here? There's some talk about disposal of wind blades in Europe. It's very conscious of if you're putting these things out, recycling them. So how does that work in the US market?
I think we're trying to figure out how that works in the US market. Again, you haven't had a lot of turbines that have been around long enough that they're getting recycled, but you're starting to see it. I think, about once a week, we have some company tell us that when we're ready to recycle our turbines, they have a new, better plan for what to do with the fiberglass. But that's the real problem. The thing that I try to maintain perspective on, though, is that if you take a wind turbine and you've got 800,000 pounds of wind turbine sitting above the ground, 600,000 pounds of that steel, that's easy to recycle. You have a whole bunch of copper, that's easy to recycle. You oftentimes have some aluminum or some other metals that is easy to recycle. And then you're left with, the fiberglass. And fiberglass is not toxic. It, is not something that's going to seep into the ground. It's just a inert trash substance, right? And so that entire turbine may have 50 to 100,000 pounds of fiberglass, right? So that's 2 semi trucks that end up going to the landfill. Now, the worst thing that could ever happen to the wind business is that they took some pictures of blades just that were cut up and laid in the landfill, looked like they were filling it before they were all compressed down to a few inches. But 1 truckload for a generator that has been powering 400 homes for 20 years with non-toxic trash. Sure, I hope we get to start recycling that and do a better job with that. But I'll take that almost any day compared to all the rest of the forms of power.
All right. So yeah, it's fair. I just don't know. That's one of the things when you hear wind, at least here, when I read articles and stuff, it's talking about recycling blades, right? That's one thing I've seen quite a bit of articles on. And then, so I get the model now. So you put these projects in, they sit for a long time. How big's your company doing? I guess, how, so it sounds like you're in growth mode, perhaps. You were talking in the pre-call about some new business you're excited about. How big's the company and what kind of mode is it in right now?
Oh, we're in why can't we grow faster mode right now. We're about 45 people today. We have more work signed or close to being signed than in the next year than we've had in the last 10 years. So there is a massive corporate change that's happening that we're seeing companies go from this is something we should look at to something we have to look at, and how fast can we go? And I don't know if COVID gave everybody some time to sit back and think about what's next, but we've seen a whole lot of companies putting their foot on the gas pedal, and there's a whole lot of room for people to come into this market and help the large industrials. We definitely see a massive transition, and now we're just trying to figure out how to keep up.
So are you seeing supply chain issues this post-COVID world and things going on? I mean, I know in other parts, I asked a solar guest the other day, and they said that they hadn't impacted them directly, but spent a lot more time sourcing than they were before. That's what they gave me.
I will say, if you ask that solar guy again today, post March 26th, you'll get the "we're completely screwed" answer. While those tariffs are pending and they're trying to figure out what to do, the entire supply chain is on hold in solar. Wind hasn't been as bad. We do see it a lot, though, in big power stuff, right? Something like 20% of the electrical grade metal that's used in transformers comes out of Russia. And so we're seeing some very interesting things happen in terms of pricing of parts that you wouldn't think would be the problem. But there are definitely supply chain issues for all in this business these days.
And so you're talking about the metal coming perhaps from a non-friendly market. Is the manufacturing of your product done in North America? Because I mean, turbines are different in North America than perhaps the European model. They don't tend to be the same from what I see. So what's different? Is the manufacturing local? I guess you're nodding. So
Well, so we brought all the tower manufacturing local. What's one of the most expensive things to ship? It's the majority of the weight. It is far easier to move the towers 100 miles than it is to move them 13,000 miles across the world. So the tower manufacturing for all of our towers has been local. The blades, it depends on the supply chain. We've got them both from U.S. Plants and from overseas plants. And then the turbines themselves, the actual nacelle, the top part with the generator, all of that tends to be overseas. We see almost none of that built in the U.S.
how much technology is in their blade? I mean, it looks like a fairly simple thing. I mean, you see the pictures when they're apart. Like if you're watching Instagram or Facebook, you'll see people standing up and where the generator is when they're putting these together and stuff. But it looks fairly simple for the ground. But how much technology is it? Like those blades and things like that.
So the technology is in optimizing the shape to do 2 things. I guess 3 things. One is last a long time. 2 is produce as much power as possible, and 3, ironically, is be quiet. And so where you've seen a lot of the innovation in the last 10 or 20 years is how do you eliminate noise, and how do you get the full bang for your buck out of that shape of that blade. The core, what is it? It's still fiberglass, occasionally with some either balsa wood or in some cases some composite stiffeners, but the majority of it's still laid up fiberglass. So there's not a whole lot of technology there. The technology is all in what the shape that you're making is.
That's pretty cool. And then you mentioned balsa wood. I remember reading about 2 years ago there was some shortage of balsa wood. There was some environmental concern with the balsa wood. So is that still a core that folks use to strengthen it, or are there synthetics that folks are using now that eliminate that? And I remember reading there was maybe 2 years or so ago there was a fair amount of articles and talk about that.
I think most of the new stuff has gone away from balsa and is going to more advanced composites. And then some of the really big blades they're building. I mean, they're building blades now that are 2.5 times longer than the blades I was building when I started in this, whatever, 15 something years ago. And so the scale of some of these blades is huge, and they have to use, everything from carbon fiber to more advanced composites.
How long does it take to build one of these projects? So if you got a call today, what's like a sales cycle? Because you got to go through a permitting and you got engineering work. I mean, so you said your phone lights up. People want to go now, but now may not be now. How long is now?
So like all good responses, it depends, Chris. So there's a number of factors. One is, how much data do we have about the wind resource at that site? So if we have no idea what the wind resource of that site is, sure, I could build you a turbine, but I have no idea what it's going to produce, and I can't finance it for you. So sometimes we have to do anywhere from 3-month to 12-month campaigns of on-site data collection. We work very hard to find data that already exists and use that data. But there are times when we say, look, like, we just need to have 6 months of data before we can give you a price, and you don't want to do this job without that anyways. If you ignore the wind portion of this, from the day that customer signs on the dotted line, the permitting can be anywhere from, we did one job in an unzoned township with no state oversight authority. We had to get a driveway permit. It was a 1-page piece of paper. We had the permit in about 45 minutes. And then we were off to construction. I also have some that have state level permitting where it's a 4 to 6 month process of going through public hearings and everything else. And so the spectrum, is pretty across the board in terms of that length. Once we have everything in hand, though, you can build a job like this in as little as 3 to 5 months. If you kind of stacked all the perfect things together, you can do it in less than 90 days, but that almost never happens because it's not that hard, right? These are just really big Legos once you get to the point of all you're doing is constructing them. So, there's a big foundation, there's roads, there's lots of cable, but when the turbine parts get there, they're just, the biggest, coolest Legos around.
So okay, so you got a cool Lego set. You're building a Rector set. You're building cool things. But you've been doing this 13 years. What kind of unexpected lessons have you learned along the way? Because I promise you didn't do it right the first time. So What have you figured out?
We've learned that when the towers get hot in the summer, for some reason, bees really like them. There's a bunch of interesting challenges about how do you get rid of bees from a tower. Ice is a lot of fun. When you build these and there's a 2-inch sheet of ice on them, that's an interesting challenge that you get into from how do you safely do that or correct that situation. We've dealt with some interesting things with turbines being shot at. Again, surprising how many bullet holes you end up patching from there. You get lightning strikes, which are fun that, the turbines are designed to take, but every once in a while, the lightning strike does enough damage. You have to go up and repair that blade. So you see that. We've dealt with a whole lot of interesting trucking incidents. It's never great when the truck carrying the tower part doesn't stay in the center lane like they're supposed to and hits the overpass. That makes for a very interesting engineering review. We had one set of towers at one point that the manufacturer was, still working their kinks out, shall we say. And when we actually bolted the thing together and tightened all the bolts, and again, these bolts are a foot long, M42, M45 bolts, 2-inch diameter bolts that you're tightening to thousands of pounds, 4,500 foot-pounds of force with 100,000 pounds of compressive force, right? Big flanges. And they tighten this whole thing up, and the guy calls down to me and goes, Jeremy, there's something wrong with the flange. What's wrong with the flange? He goes, there's a gap, man. I'm like, what do you mean there's a gap? Like, how big's the gap? And he goes, bro, I can see the fucking corn. And so he was actually looking through the completely compressed flange gap and seeing the farm field. And so now all of a sudden you have 100,000 pound sections that are bolted together that you have to figure out how to deal with. And we ended up having to take them down and machine them flat on site and put it back together. So that's never a fun experience. But I think that's probably the headlines of kind of the fun stuff that you're just like, wait, what just happened? that comes up, but every new project seems to bring its own fun challenges, no matter how much we try to standardize.
How about on the other side of the equation? So that's learning to build and put your erector set and your Legos together and have them safely operate and get transported. What about on the customer side? What kind of lessons have they learned in these projects?
Yeah, we've learned a lot about what it takes to get corporate approval, and what it takes to get corporate risk, right? So there's a lot of interesting questions from an accounting point of view about when do these contracts become leases. And so if you are a large company and your electricity costs for a factory are currently an operating expense, what you don't want to do is sign a document that takes 20 years of that and capitalizes that as a lease, because it makes your financials look pretty weird for a long time. And it makes it look like you just lost a whole bunch of money or aren't making the money you were making before. And that's not a good thing. So we do a lot to make sure that these contracts stay operating contracts and don't become leases. We've also seen companies, realize that if they want to do more of this, they have to look at their whole plant and their whole power system. That's the real enemy to adoption, right? The real enemy to adoption for this is that, most factories out there operating today have power systems that are 30, 40, 50 years old that were never designed to put a whole bunch of on-site generation in that. So you're doing a whole lot of, how do you rebuild a 50-year-old power system? And customers are realizing that they have to factor that in because, what worked in 1960 is not what's going to help them go to net zero on site right now.
Okay. So you talk about upgrading legacy systems. You talked about power plants and all that, a little bit long in the tooth, perhaps on the grid. What kind of changes need to take place in the grid? So if this infrastructure is well adopted, you've talked about the demand there. So suddenly you offload the grid for part of the time. So some of the demand is down. And so maybe I charge more electric vehicles or fleets or whatever from grid power because I need power elsewhere as everything else electrifies. But at a certain time, I'm still needing the base load when I want it. What needs to happen to the grid for you to live symbiotically together and happily?
I think it's symbiotically and happily would be a dream, I guess, right? The the grid talks so slow it's hard for us to understand. Um, a lot of the grid still communicates through phone lines. A lot of them are working on getting internet to substations. The grid schedules power on 15-minute intervals in most cases, right? And a lot happens to power in 15 minutes. And so getting to where the grid can talk faster, but the real problem becomes, what do you talk about? And what do you talk, who do you talk to? And so if I'm a factory with a large amount of distributed generation, how can I talk to that substation enough to know, what that substation's condition is right now? How close is it to being stressed? Can it take all the power I can produce? Is it having a problem? And at some point, um, somebody has to get the old legacy grid operators to be able to talk to the new state of the art, generation and figure out how to work together and figure out what's fair, right? Can I, as a factory, just do what's best for me? Or do I have to do what's best for the grid? Or is there some in between? Or do I get paid for doing more than what's best for me and and helping the grid out? And no one's written those rules and no one's really solved that problem. And so at some point, in order to make this work at scale, you're going to need to have the old substations talking to other substations and switching stations, talking to large energy users about their loads, talking to the generation that those users have, and figuring out how to have everybody make a decision that works for them, that doesn't completely screw the other guy. And that's the real challenge. That's what the next 20 years is about, and innovating in a cycle where we we're buying some new equipment for our substations that we're building, and we're talking about fiber optic integration, right? And if you think about fiber optics, they've been around for 40, 50 years, right? They're in everything. We were talking before this call about the fiber optic lines coming into this building. They don't use fiber optics for communications inside substations in most cases, right? So they're sitting there having big pieces of equipment talking, and they aren't using Ethernet. They aren't using fiber optic. They're still using copper wire. And the idea that that's still the system that's being used. And so we asked the suppliers, we said, look, you've got these fiber optic options. Why isn't everybody buying this? And they go, well, the utilities just don't want to change. We go, what do you mean? And they said, well, the utility said we have to retrain our people if we did that. So it's easier to stick with what we know. And if you think about that cycle that's building the power grid around you, that becomes a very toxic cycle where the utilities are 20, 30, 40 years out of spec. And that's what creates all the risk we talk about on the grid from a resiliency point of view. It's what creates the exposure for the power system. And it's what makes it harder and challenging to go in there and be a good actor with behind the meter stuff, as opposed to just being a self-serving actor.
So does that drive change when we start having rolling blackouts? Does that change come when so many people start building microgrids because they don't trust the grid? I mean, what's the forcing function? Is it just regulation and say it's energy security and it's national security kind of stuff? And hey, we need to just take this and bite the bullet and do this. What's going to change that?
It's Texas, Chris. It really is, right? Something has to go horribly wrong. Unfortunately, Americans and legislators are pretty stubborn, and so they don't take action until a bunch of people die and get hurt. And then at some point, someone says, we've got to fix this. But even after Texas and ERCOT happened, right? And by the way, everybody in the power business knew exactly what happened in Texas because there was a report about how that happened and almost did exactly that 10 years before, and nobody fixed it. And so, you get 2 weeks of speeches, and then everybody kind of forgets about it again, and we'll figure it out later on. And so it's going to take some bad stuff to force the change because no one's going to do it on their own. And that's the really kind of frustrating part. What I do think you have happening, though, is you have the mega users, right? So we talked about the 53,000 large facilities that are the large energy users. They represent only 0.6% of the consumers, but they're more than a quarter of the energy used. They're starting to take things in their own hands because it makes economic sense for them to do that. And as they start taking things in their own hands, they start having more and more generation on site, more and more high-speed switching, power quality type instrumentation, more storage, more whatever else. That 26%, I think, is what's going to force everybody else to act, if for no other reason than to try to get control of the 26%. But the 26% are making changes now because they've realized that to not do that, it means to rely on a supplier who just doesn't really care.
All right, so you're out there. You've got one section of the country covered. You've got a number of companies stepping up. I'm assuming there's competition in your space. How competitive is the space to do? You talked about solar as a clear competitor. Are there other competitors trying to do the same thing in wind?
Yeah, so I think you have to be basically clinically insane to start a company that does this behind the meter for wind. It's very challenging to do behind the meter wind projects. It's why you don't see a lot in this space. Behind the meter solar is absolutely a competitor that you see a lot of. You're starting to see some behind the meter, hydrogen type activities. You're starting to see people trying to do storage and have, it's smaller scale making that work. You see some behind the meter geothermal, and then you see a bunch of kind of the fuel cell type behind the meter things too. So everybody's trying to figure out what works. The real reality is that none of those work on their own. Wind alone does not work, right? Solar alone does not work. Fuel cells alone do not work. You have to find the right way to blend those together, and you blend them together based on your risk appetite, your financial appetite, and your sustainability appetite. I mean, every factory could go install, a big old cat diesel generator and have all the power they wanted, but it would cost too much and have way too high of emissions. But that's a solution that works tomorrow. And so trying to find the right balance of, risk, resiliency, financial profile is where all the competition is, and everyone's selling their part of it. And I think what you're going to see a whole lot more of is customers saying, look, I'm going to take that one, and take that one, and combine them to get what they want. Because Whirlpool might have a different goal than Ball and a different goal than a Marathon refinery. And so they all have to figure out what the appropriate, goals are for them.
So do you see your company 5 years from now being like an integrator where you would have taking that wind experience you have and saying, okay, well, if I'm going to go to Whirlpool or Ball or whatever, whichever of these corporates and deliver a solution, they're probably going to put one RFP out, and I'm going to probably need to have multiple solutions in my pocket. Is that where you see yourself in 5 years?
I think that's where we see ourselves now, Chris. It's what we're getting pulled into already. I did not plan on starting to build, just pure power infrastructure, but our customers are asking us to, so that they can connect other things together. They're saying, if you're going to upgrade me, right, and you just scolded me for not having an upgraded system, how do you upgrade me in a way that makes me future proof? How do you upgrade a system where I can plug in the next thing I want, the solar thing, the EV charging, the fleet charging, all without taking my other stuff down, which is a whole new way of thinking about how do you design an electrical system for a power plant. Designing it to be constantly expandable is an interesting problem. And we're doing that on a few sites already, because our customers have said, look, if we're going to future proof, we're doing this one time. So go future proof us. And so I think you're going to see a whole lot more of that. And then a whole lot more of the customer saying, great, now that you've done that, I want to pull this in and pull this in. And hey, someone just invented some magic thing from a unicorn they discovered and figured out how to make, whatever else. Go plug that in too. Great. But every customer is going to constantly be shopping for themselves instead of sitting around hoping the utilities are taking care of them.
Well, I think it's been an interesting conversation. We've been a bit all over the place. You don't give me comfort that the grid has got things figured out right now. In fact, you give me a little discomfort that the U.S. grid is really on top of where it needs to be, but it's consistent with every other data point I have. So you haven't surprised me. I think it's interesting to hear that the types of companies and the types of names you're throwing around that are using this kind of wind power for their plants and their operations and the scale that it is. The statistic, I think you said with the 23% or the small amount of users that use a fair amount of the power, that to me was pretty interesting. I think it's been a great journey. I want to thank you for coming on and sharing your story. Look forward to hearing more about more projects you win and hearing maybe some wins in the near future from you guys. Thank you so much for being a guest on the program.
Thanks for having me, Chris. I appreciate the time.
And to our audience, you spent another hour listening to Insider's Guide to Energy. I hope you've enjoyed this content as much as I have. If you have, don't forget to share it. Don't forget to like it. And don't forget to check out the YouTube channel. It's always interesting to see what we look like with the voices. And we'll talk to you again next week. Bye-bye.